Negative exponents, negative exponents, negative exponents. We can't have them, we shouldn't have them, we have to fix them. Anytime you see a negative exponent, red flag, fix it, fix it, fix it. When the base is powered by the negative exponent, you must take the reciprocal so that that exponent becomes positive. So let's look at what that looks like. I have x to the power of negative m. We all know that when we see a base, when we see an integer, we know that it sits on top of 1. In order for us to take that x to the power of negative m and make that exponent positive, we have to flip it. We have to take its reciprocal. So what we do is we flip it and we have 1 over x to the power of positive m. That may have went over your head, but it's really, really simple. You see a negative exponent, take a reciprocal of that fraction, and the exponent becomes positive. Simple. Let's look at another example of that. Let's say we have 5 to the negative power of 3. Flip it. We know that 5 to the negative power of 3 is over 1. We're going to flip it. We're going to put 1 over on the top, and we're going to put it over 5 to the positive power of 3. So that exponent becomes positive, exactly what we want. So we end up with 1 over 125. The same thing if it was the other way. If we have 1 over 3 to the power of negative 2, we're going to flip it. It becomes 3 to the power of positive 2 over 1, which is just 3 to the power of 2, which is definitely equal to 9. Be careful. You never want to have a negative exponent. Anytime you have a negative exponent, take its reciprocal and the exponent becomes positive. Be careful when dealing with problems involving negative exponents. It can be complex, but it's definitely not complicated. Let's practice. Let's practice. Let's practice. Let's practice. Let's practice. Okay, let's look at some examples involving negative exponents. Remember, anytime you have a negative exponent, take its reciprocal and the exponent will become positive. Number 1. Let's say we have x to the power of negative 5. I'm going to imagine this over 1, right? Because we all know this is over 1. And in order to get this negative 5 to be positive, I'm going to take the reciprocal. So this becomes 1 over x to the positive 5. And that's what that would look like. Let's do another simple example. Number 2. Let's say we have 1 over 4 to the negative second power. Again, in order to make this 2 positive, or this exponent positive, I'm going to take the reciprocal. So this becomes 4 squared over 1, which is just 4 squared, which is equal to 16. Remember, take the reciprocal in order to make those exponents positive. Let's look at a harder example. Example number 3. Let's say we have negative 4 x to the 5th y to the negative 7th. Right, I'm going to look at this problem closely. I'm going to go through it very carefully to see what needs to change. So I can look at this a few ways, but I'm going to look at the most simple way. This is technically over 1. So I'm going to check. My negative 4 have an exponent of 1, so it's good. It doesn't have a negative exponent. It can stay in the numerator. My x has a positive 5 exponent, so it can also stay in the numerator. But my y to the negative 7 is unacceptable, which means I have to flip it, which means it now becomes a part of the denominator and becomes y to the power of positive 7. And this would be my final answer. If I wanted to break this apart just so that you understand exactly what's going on, I have negative 4 over 1 times x to the 5th over 1 times, I need to flip this, right? This is y to the negative 7 over 1, but I'm going to have to flip it. This negative 4 is good to stay over 1 times the x to the 5th is good to stay over 1, but this y has to be flipped and it becomes a part of the denominator. I multiply straight across, I get negative 4x to the 5th over y to the positive 7. And this is exactly what we have here. I just wanted to do it in a little more detail so that you understood exactly what was going on.